The next topic that I'm going to teach you is going to be about the dot product or the scalar product of two vectors A and B. So when you have two vectors A and B given by A1, A2, A3 and B1, B2, B3, okay, so we're going to define the scalar product or the dot product between these two vectors to be the product that you have from each component. So you're gonna have A1 multiplied with B1. So it's gonna be A1 multiplied with B1, the first component multiplied together, A2 multiplied with B2 and A3 multiplied with B3. And you're gonna sum this number up. So this guy turned out to be a scalar or real number. So we call this guy a scalar product or the dot product. So it's not going to turn out to be vector anymore. So it's going to be scalar instead. Okay. The next one that is going to be about the property of the dot product. When you have a dot A, so if I wrote here a dot A, it's gonna turn out to be a1 square plus a2 square plus a3 square, and this guy turned out to be just the norm of a square. So this guy is equal to norm of the vector a square. Okay, so that will be a dot a. So you can use the dot product in order to find the norm of the vector A. So the norm of the vector A will be given by square root of A dot A. And the A dot B will be equal to B dot A. So you no need to worry about the order of the vector that you have dotting. And if you have theta is the angle between two vectors A and B. So you see this picture. So you have theta is the angle between vector A and vector B. So you're gonna have by the law of cosine. So this guy comes from the law of cosine. That you're gonna have A dot B equal to norm A, norm B, cosine theta. So this one, sometimes we call this guy the norm of A. Okay, so it's gonna be the norm of A or the length of A or the magnitude of A. So norm, magnitude, or length of the vector A is going to be the same meaning for this one. Okay, so for this one, sometimes I call this guy the norm of A, and A dot B turn out to be equal to norm A, norm B cos theta. And if you like to solve for cosine theta, so you're going to be able to solve for cos theta. Cos theta will be A dot B over norm A, norm B. Okay, so it's going to be cos theta equal to A dot B over norm A, norm B, where A and B are non-zero vector. So this one is going to be useful. Okay, so this is used to find the angle between two vectors A and B. So if you like to know theta, you're gonna answer in terms of r cosine A dot B over norm A, norm B. Okay, so that is gonna be the thing that we will kind of use a lot also. So let me emphasize on this one a little bit. Okay, so we use this one a lot, and it's going to be used regularly for finding the angle between two vectors. The next one asks you to find the angle between the vector A given by 2, 1, negative 2, and the vector B given by 0, 4, 3. So in this case, we're gonna have cosine theta equal to, okay, let me write down the formula, A dot B over the magnitude of A, the magnitude of B. So you're gonna find just A dot B, so it's gonna be 2 times 0 plus 1 times 4 plus negative 2 times 3, okay? And this guy will be over the magnitude of A, so it's going to be square root of 2 square plus 1 square plus negative 2 square. And you have square root of B, so it's going to be 0 square plus 4 square plus 3 square. Okay. And you see that the calculation will lead you to 2 times 0 is 0, so it's going to be 4 minus 6, okay, so it's going to be minus 2 on top, okay, and on the bottom you would get square root 9, okay, and you're gonna get square root 25, okay, so it's gonna be negative 2 over 15 on the bottom. So you're gonna answer theta in terms of cosine of negative 2 over 15. Okay, so we no need to simplify this one further. So it's gonna be just cosine negative 2 over 15. The next one, the question asks you if the vector A and the vector B have length 4 and 6 respectively, and the angle between them is pi over 3. The question asks you to find A dot B. So you see that we shall apply the formula A dot B. Okay, so we're gonna apply the formula A dot B equal to norm A, norm B, cosine theta. Okay, so I'm gonna copy this guy down here. Okay, so we have A dot B equal to this. So you're gonna just plug in the formula. Norm A equal to 4, norm B equal to 6, theta equal to pi over 3. So it's going to be 4 times 6 times cosine pi over 3. Okay, so it's going to give you 24, and cosine pi over 3 is 1/2. So A dot B equal to 12. Okay, so this is how we obtain the solution. The next one is going to be about when you have two vectors and you like to determine whether they are perpendicular or orthogonal. When you have perpendicular or orthogonal, it does mean that you have two vectors in this way. So you have A, you have B. So this one will be the vector A and B. So it's gonna be A, it's gonna be B. Okay, and the vector that we have perpendicular is mean the angle between them is 90 degree or pi over 2. Okay, so it's going to be right angle here. Okay, so good enough. So when you have the angle between them equal to pi over 2, it's gonna affect when you have A dot B. So it's gonna be A dot B equal to norm A, norm B, and cosine pi over 2. And cosine pi over 2 will be equal to 0. And it's gonna make A dot B equal to 0. So in this case, we can conclude that if you have A and B are orthogonal or perpendicular, you're gonna have the criterion in order to determine this guy to be A dot B must be equal to 0. Okay, so you have A dot B equal to 0, and you're gonna be able to show that these two vectors are perpendicular. So we like to show that this vector 2i plus 2j minus k is perpendicular to the vector 5 minus 4j plus 2k. So you're gonna have this guy I'm gonna call A, and this guy I'm gonna call B. So you're gonna compute A dot B. Okay, so A dot B will be 2 times 5 plus 2 times negative 4 plus negative 1 times 2. So you see that it's going to be 10 minus 8 minus 2 equal to 0. Okay, so it's going to be A and B are perpendicular. Okay, so that is going to be this vector. Okay, the next one is going to be about the directional angle and the direction cosine. So the direction angle will be the angle that the vector make with the x-axis and the y-axis and the z-axis. So if you see from this picture, you see vector A, and you see that the vector A make the angle alpha with the x-axis, make the angle beta with the y-axis, and make the angle gamma with the z-axis. So we like to determine alpha, beta, and gamma. They will be called the direction angles. So it's going to be the angle that is made with the x-axis, the y-axis, and the z-axis respectively. So the way to obtain this one is going to be, you see that you allow to use the vector ijk. So if I draw my vector I, my vector j, and my vector k, okay, so I have my vector I, vector j, and vector k. Okay, so you be able to find the angle alpha by using the thing that called direction cosine. So from the formula for the dot product, you gonna have cos alpha equal to A dot I over norm A, norm I. So norm I is equal to 1. Okay, so it will disappear, and when you have A dot I, it's gonna turn out to be just the first component. So your vector A turn out to be just A1, A2, and A3. When you have your A dot I, it's gonna be your first component, A dot J gonna be the second component and A dot K will be the third component. Okay, so that will be just A dot I, A dot J, and A dot K is gonna give you the first, the second, and the third component respectively. And you're gonna have the norm of J turn out to be equal to 1. And the norm of K turn out to be also equal to 1. So you're gonna have the formula for the thing called the direction cosine given by cos theta equal to the first component over norm of A, cos beta equal to the second component over the norm of A, and cos gamma equal to the first component over the norm of A. Okay, and you have norm of A square equal to A1 square plus A2 square plus A3 square. So when you have cos alpha square, cos beta square, cos gamma square, it's turned out to be the sum between A1 square over norm of A1 plus A2 square over norm of A2 plus A3 square over norm of A square. So you're gonna have A1 square, A2 square plus A3 square. So this guy come from this relation, and it's gonna be over norm of A square. So this guy turned out to be equal to 1. Okay, and you're gonna be able to have A. Okay, so the vector A turned out to be A1, A2, A3, and you can see that from this relation, you're gonna have A1 given by norm A multiplied with cos alpha, A2 given by norm A cos beta, and A3 given by norm A cos gamma. So these are the terms that you have here. So you have the vector A given by equal to norm A cos alpha, cos beta, cos gamma. Okay, let's do one example on direction angle and the direction cosine. So we like to find the direction angle of the vector A given by 2, 1, and 3. So you will need norm A. Okay, norm A will be square root 2 square plus 1 square plus 3 square. And this one will be square root 4 plus 1 plus 9. Okay, so it's going to be square root of 14. Okay, so it's going to be of square root of 14. Okay, so you get cos alpha, okay, equal to the first component over square root 14 cos beta equal to 1 over root 14 and cos gamma equal to 3 over square root 14. Okay, so it's gonna be 2, 1, and 3 respectively. Okay, so this is how we obtain cos alpha, cos beta, and cos gamma. So if you like to find alpha, it's gonna be answered in terms of r cos 2 over root 14. Beta will be r cos 1 over root 14, and gamma will be r cos 3 over root 14. Okay, so that will be the angles alpha, beta, and gamma respectively. The next important thing is going to be about one application of the dot product. for finding the length of the projection vector. When you have two vectors A and B, sometimes we like to find the projection of A onto the projection of the vector B onto the vector A. What does it mean? The thing that I like you to see will be, you see that you have your vector A, which is your vector PQ here, and you have your vector PR, which is your vector B, and you're gonna imagine that you have a light here. Okay, so imagine that you have a sunlight, or you have a bulb here that is gonna be the light, and you're gonna project this guy. So this guy is gonna be the shadow. Okay, so you see the shadow here, and you like to know the length of this vector PS. This guy is called the projection vector. Okay, so this one is called vector projection. Projection of B onto A. Okay, so it's going to be vector projection of B onto A. And you're gonna have that. Okay, so you're gonna have that. The projection, the vector projection of B onto A, so it's gonna be this shadow. And the way to find this vector will be, you see that if you have theta. Okay, so we like to find this one. So if you have theta here, okay, which is this angle, let me make this one clearer, darker a little bit. So if you have theta, which is this guy, okay, so you gonna see that from trigonometry, it's gonna be that you have the norm of the projection. Okay, so the norm of the projection over the norm of B turn out to be equal to cosine theta. Okay, so from this picture, the thing that you can see will be, you see that from this, you're gonna be able to conclude that, okay, so you can conclude from this picture that you have the norm of the projection turn out to be norm B cosine A, and you can have the norm of the projection equal to norm B cosine theta. Okay, so it's going to be norm B cosine theta. If you multiply the top guy with norm A and you divide by norm A, the thing that you're gonna get will be, you see that this numerator turned out to be just A dot B. Okay, so it's gonna turn out to be A dot B. So that will be the blue guy. And it's gonna be over norm A. Okay, so it's gonna be A dot B over norm A. So you see that the norm of this vector or the length of the shadow. So this one, I would say that this will give you first the length of the shadow. So the length of the shadow turned out to be equal to this number, norm B cos theta. Okay, so it can be norm B cos theta. Okay, so it will be norm B cos theta, or another thing will be just A dot B over norm A. Okay, so it's going to be A dot B over norm A. Okay, so that will be the length of the shadow. Okay. However, if you like to find the projection vector, okay, so what is the projection vector? If you like to find the projection vector, the projection vector turned out to be the vector in the same direction of the vector A. Okay, so you see that this one is going to be the vector A, so it's going to be same direction as vector A. Okay, so it's gonna be the vector that you are having the same direction of vector A, and it's gonna be of length norm projection of B. Okay, so in order to have that kind of stuff, it's gonna be you're gonna compute the unit vector. Okay, so it's going to be the unit vector, okay, multiply with the length. So it's going to be, okay, so let me write first and I'm going to explain this one. So you're going to see that it's going to be unit vector and you multiply with the norm of the projection. Okay, so we're gonna have what is the norm of the projection? So it's going to be A dot B over norm A. Okay, it's going to be A dot B over norm A multiply with A over norm A. Okay, so it's going to be A dot B multiply, so it's not dot, let me multiply. So it's going to be like this. I need to write this guy in a curly way. Okay, so it's not going to confuse you. Okay, so for this one, that will give you the projection vector. Okay, so you see that this one, when you memorize this one, is going to be given by the green vector. Okay, so it's going to be A dot B, okay, A dot B over norm A square over norm A square multiply with, not multiply with, multiply with your vector A. Okay, so multiply with your vector A. I should not write in this way. It's gonna be the red guy, okay, A dot B, okay, over, and you have norm A square, and you have vector A like this. This one turned out to be scalar. Okay, so the yellow guy is scalar. It's kind of difficult stuff. Okay, it's kind of difficult stuff. However, it's not that difficult to understand. The thing that you will need will be just two things. It's gonna be the projection vector here, or the vector projection will be given by this formula. Okay, you don't need to know how to prove it. So it's going to be just the projection vector is going to be A dot B over norm A square multiplied with vector A. And the length of the projection turned out to be A dot B over norm A. And we're going to have the special name for it. The special name is going to be the scalar projection. It's going to be the component. Okay, so it's going to call the component of B onto A. So this one is going to be just the thing that I wrote earlier. So it's going to be the length of the projection. Okay, so this one is going to be the just the length of the shadow. Okay, so let me highlight this one a little bit for you. Okay, so it's gonna give you the length of the shadow. Okay, and the vector PS. Okay, so the vector PS will be just given by this projection. Okay, so this one is gonna be norm of PS. Okay, and it's gonna be PS, it's gonna be A dot B over norm A square times A. Okay, so if I give you two vector, okay, so if I give you two vector, the question will just basically ask you two things. So it's gonna be ask you to find the component or ask you to find the vector projection. Okay, let's try one example. I'm gonna draw a nice picture for you here. So you have A given by negative 2, 3, 1. Okay, so you have A. Okay, so it's gonna be negative 2, 3, 1. And you have B given by 1, 1, 2. Okay, so it's gonna be B. If you study physics, you may ask for the projection. Okay, so this one will be just you have the right angle, and the question may ask you to determine this projection. So, okay, so this one will be the thing that call what is called the projection. Okay, so it's going to be the projection of A, B. Okay, so it's going to be projection of B onto vector A. So this one, you just apply the formula. So it's going to be just A dot B over norm A square, and you multiply everything with A. Okay. So the thing that you can compute will be just you compute A dot B. Let's compute A dot B here. A dot B is gonna be negative 2 times 1, okay, plus 3 plus 2, so it will be 3. And norm A is gonna be square root of 4 plus 9 plus 1. So it's gonna be 3 over, not 3 over, so it's gonna be square root 14, okay? And you're gonna have 3 over root 14 square times A. Okay, so you get 3 over 14 multiply with the vector negative 2, 3, 1. Okay, and the next one, you're gonna find the component. Okay, so it's gonna be A dot B over norm A. So it's gonna be 3 over root 14. Okay. So this one will be the component, and it's going to be the vector projection that you have. Okay, so the question will be maybe, not the question, the formula may be a little bit confusing. However, the thing that you're going to use is going to be very, very simple. You're going to get A and B, and you're going to just plug into the formula, and that's it. You get vector and you get number that you have. Okay, so that will be your final answer, and I hope that they're not hard to compute. Okay, the Next topic, which is gonna be our last topic for this lecture, is gonna be about the cross product. The cross product between two vectors will also be useful in order to find the vector that perpendicular to both vector A and B. So you have vector A given by A1, A2, A3, and the vector B given by B1, B2, and B3. We're gonna define the cross product of these two vectors to be the determinant. You're gonna have the determinant with 3 by 3 matrix. So it's gonna be IJK. So you're gonna use IJK on the first row, and you're gonna use your vector A in the second row, and you're gonna use the vector B on the third row. Okay, so when you have A cross B, it means that you have IJK on the first row and you have A on the second row and B on the third row. So let me erase this one a little bit so we're gonna see this guy clearer. And you're gonna compute this determinant by computing. So it's gonna be, you're gonna have I, J, and K respectively. So you're gonna have I, J, and K. So you're gonna have the term multiply with I, multiply with J, and multiply with K. The term that you multiply with I will be, you're gonna cut the row that involving I and the column involving I like this. So you see that the thing that you have left turn out to be A2, A3, B2, and B3. Okay, so you're gonna just cut the row that involving I and the column that involving I. Okay, for J, it's gonna be the row involving J and the column involving J. So you see that you end up with A1, A3, and B1, B3. And you see that this one corresponds to the thing that you have left here also. Finally, for K, it's going to be, you're going to cut the row and the column involving K, and you see that you're going to get A1, A2, B1, B2 correspond to A1, A2, B1, B2 that you're going to write here. However, the important thing will be you're going to have the minus sign here. Okay, so let me emphasize by a different color. So it's going to be the minus sign here. Okay, so here you're going to have the minus sign, and here you're going to have the plus sign. Okay, so the minus sign is going to be here. Okay, and you're gonna find the number here, which is also called the determinant, by you're gonna multiply this guy down and you're gonna multiply this guy up and you subtract them. So in this case, you're gonna have A2 B3 minus A3 B2, okay? And you have A1 B3 A3B1, okay? And you have A1, B2, A2B1, okay? So this is how we compute this number. I'm gonna teach you step by step by doing one example for you. So you have two vector A equal to 2, negative 1, 3, and B equal to 3, 2, 0, and you like to find the cross product. I forgot to tell you the name. The name is gonna be the cross product. Okay, so the name is called the cross product of vector A and B. Okay, so the way to find this vector is gonna be, you're gonna set up the determinant. So it's gonna be I, J, K on top, and you're gonna have 2, negative 1, 3, 3, 2, 0. Okay, and you're gonna have the term that you're gonna cut the row involving I and the column involving I. So you see that you get negative 1, 3, 2, 0 left. So it's gonna be -1, 3, 2, 0, and you have I. Okay, so you're gonna have I plus, not plus. So here it's gonna be minus. Okay, so you get for J it's gonna be 2, 3, 3, 0. Okay, so it's gonna be 2, 3, 3, 0. Okay, so it's gonna be your J, and finally you have your K. So it's gonna be, for your K, it's gonna be this guy. So it's gonna be 2, -1, 3, 2. And it's gonna be your K. Okay. So you get I, J, K like this, and you're gonna compute this one. So it's gonna be one come down. Okay, so it's gonna be 0 minus 6 I minus 0 minus 9 J plus 4 plus 3K. Okay, so it's gonna be -6 I minus, so it's going to be plus 9J plus 7K. Okay. So this will be the vector A cross B. Okay, so let me move this one a little bit. Okay, so it's gonna give you A cross B. Okay, so it's gonna be this vector. Okay, the thing that I like to do next is gonna be, I like to find B cross A for you a little bit. Okay, so for B cross A, it's gonna be, for B cross A, it will be the same thing. However, the setup will be a little bit different. So you have I, J, K, and you're gonna have the green vector differently. So it's gonna be 3, 2, 0, and 2, -1, 3. Okay, and for this guy, okay, so for this guy, it's gonna turn out to be, okay, so it's gonna turn out to be, you see that you're gonna close I, okay, you get to 0, -1, 3, close J is gonna be 3, 0, 2, 3, and close K is gonna be 3, 2, 2, -1. So it's gonna turn out to be, let me write down to 0, -1, 3, and you have I minus J is gonna be 3, 0, 2, 3, J plus K is gonna be 3, 2, 2, -1. Okay, and then you're gonna have, okay, so you're gonna have 6 minus 0 I minus you have okay, so you're gonna have 9 minus 0 j, and you have negative 3 minus 2 minus 4, sorry, k. Okay, so this one will be just 6i minus 9j minus 7k. And you see that the numbers that you have are identical. However, the difference turned out to be on the side. So you have A cross B equal to negative 6, 9, and 7. However, you have B cross A, so B is 6, negative 9, and negative 7. They're gonna be the same except the direction. So this guy will be equal to negative of A cross B. Okay, so the important notice is gonna be B cross A turned out to be equal to negative of A cross B. Okay, so the thing that you have extra turned out to be negative. Okay. So we're gonna conclude the property that important here, that when you have A cross B, so it's gonna be negative B cross A, okay? Another thing that I like you to notice will be if you have A equal to 2, negative 1, 3, A cross B equal to negative 9, not negative 9, negative 6, 9, 7. So you see that, okay, if you compute A dot A cross B, let's find A dot A cross B. When you have A dot A cross B, it's going to be 2, negative 1, 3, U dot with negative 6, 9, 7. Okay, so this guy become what? This guy become negative 12. Okay, so negative 12 minus 9 plus 21, and it's turned out to be 0. Okay, so that will be A dot A cross B. Okay, so you see that A dot A cross B equal to 0. I want everything written, so I need some space. Let's write it again. Okay, so I'm gonna use this big space. So I have A dot A cross B turn out to be 2, negative 1, 3 dot negative 6, 9, 7. So this guy turned out to be negative 12 minus 9 plus 21 equal to 0. And you have B dot A cross B. Okay, so it's gonna be 2 not 2. It's gonna be 3, 2, 0 dot negative 6, 9, 7. Okay, so you get negative 18 plus 18 equal to 0. Okay, so you see that you have A dot A cross B and B dot B A cross B, they both are equal to 0. So you have A must be perpendicular to A cross B, and B must be perpendicular to A cross B also. Okay, so they're perpendicular to each other like this. Okay, so that will be another important property. So it's gonna be you have A is perpendicular to A cross B and B is perpendicular to A cross B. So it's gonna be the first property that we have here. Okay, the vector A cross B is orthogonal to both A and B. Okay, so that is gonna be this picture. Okay, that kind of important. This one, we use A cross B when we like to find the vector that perpendicular to both A and B. Okay, so this vector, okay. So we use A cross B when we would like to find the vector, I'm gonna say a vector that perpendicular to both A and B. Okay, so when we like to find the vector that perpendicular to both A and B, you simply use A cross B. The next one will be the norm or the magnitude of A cross B. The norm or the magnitude of A cross B will be given by A cross B, norm of A cross B equal to norm A, norm B sine theta. So this one is a little bit difficult to prove, so I'm not gonna show you how to obtain this guy. If you like to know, so you can study it from the textbook, okay? And we not normally use this one, okay? So we not normally use this one because if you like to find the norm of A cross B, you can just find A cross B and you just take norm. It would be easier, okay? So that is gonna be another way in order to find the norm of A cross B instead. Another important thing is going to be when you have two non-zero vectors are parallel, okay? So if you have vector A and vector B are parallel, what does it mean? A parallel to B, okay? So this symbol, okay? So the symbol here is going to be like you have two lines that parallel to each other. So it's going to mean A is parallel to okay, so it's going to be A is parallel to B. It means that A and B are in the same direction. So you have vector A and you have vector B. Okay, so it's going to be this one, or you have B in an opposite direction. Okay, so they can parallel in this way. It means if you consider them as a straight line, they are going or they are pointing in the, they basically it's gonna call parallel. Okay, so for this one, it's gonna turn out to be so for this one, it's gonna turn out to be, okay, A is gonna be multiple of B. So in this case, it's gonna be if and only if, okay, so let me write it down here. So this one is gonna be A is a multiple of B, okay. What does it mean for A is a multiple of B? It means that you have A is constant, B like this, okay? So it's gonna be the multiple of B. So it's gonna be A, gonna be constant multiple. So you're gonna have constant C, okay? That play a role here, and it's gonna be A, gonna be like a equal to C times B, okay, so that is mean parallel. Normally we're going to use parameter T for this job, okay, so it's going to be parameter T in order to determine parallel, okay, so it's going to be A is a constant multiple. For example, A equal to 3B, okay, so it's going to be like a parallel, or A equal to negative 2B, okay, so it's mean they parallel in that way. Okay, the next one, okay, is going to be how we use the norm of the cross product in order to do the calculation. So if you have vector A and vector B, okay, so if you have the vector A and the vector B and you have the angle between them equal to theta, you're gonna be able to find the height of this parallelogram. So if you draw a parallelogram that you have A and B are side of this parallelogram, so it's gonna be that the height turn out to be equal to norm B sine theta. So this one gives you the height. Okay, so this one gives you the height, and you have the area given by the base. Okay, so this one is going to be the product between the base multiplied with the height. Okay, so you have the base multiplied with the height. So it's going to be norm A, norm B sine theta. And norm B, norm A sine theta turn out to be norm of A cross B. Okay, so it's going to be norm of A cross B. Let me do one example for you. We like to find the area of the triangle with vertices P 1, negative 1, Q 3, 0, 1, and R 1, 3, negative 2. So we have this PQ, okay, so it's going to be P, and it's going to be Q, okay, so it's going to be P is 2, 1, negative 1, and you have Q given by 3, 0, 1, okay, and you have your R given by 1, 3, negative 2, okay. You like to find the area of this triangle. Okay, so you like to find the area of the triangle P, Q, and R. Okay, so the way to do this one will be you're gonna construct, or you're gonna fill the picture and make this guy into a parallelogram. Okay, so you see you'll be able to make this guy into a parallelogram like this. Okay, so you make this guy into a parallelogram, and you see that you have vector A and vector B. Okay, so you can have vector A and vector B. Okay, so the area turn out to be, okay, so the area of the triangle PQR, okay, turn out to be half of A cross B. Okay, so it's going to be half of A cross B. Okay, and A turned out to be PQ, and B turned out to be the vector PR. So this guy will be PQ cross PR. Okay, And let me find PQ and PR here. So PQ is going to be Q first, subtract by P. So it's going to be 3 minus 2, 0 minus 1, and 1 minus 1. Okay, so this guy will be 1 minus 1 and 2. Okay, and that my PQ. And you have your PR given by, okay, so for PR is gonna be, yeah, so it's gonna be 1 minus 2, 3 minus 1, and you have negative 2 minus 1. So it's gonna be negative 1, 2, and negative 1. Okay, so we're gonna find PQ cross PR. So it's gonna be IJK, okay, and you're gonna write 1, negative 1, 2, negative 1, 2, negative 1, okay, and you're gonna compute this cross product for me, okay, and you're gonna conclude the area of the triangle PQR. Okay, so it's going to be the norm of the thing that you're gonna get here. Okay, so norm of the thing that you're gonna get and divide by 2. I'm gonna leave this one, okay, for you to do on your own, and I'm gonna give you the solution for this one, complete solution, when we have the recitation. Okay, so I let you practice cross product between two vectors on your own first. By the way, I would like you to check your solution. After you have your cross product, you should check your solution whether you get the cross product. Okay, so when you have the cross product, you should check your solution whether you get your cross product dot A cross product dot B turn out to be 0. It's gonna be useful, okay, to check whether you get the correct answer. Okay, so when you do the cross product, I suggest you to check the solution all the time in order to obtain the correct answer. Okay, so you just have your cross product dot with vector A and vector B that you begin with to see whether you get 0 or not. And the most mistake that you make turn out to be on the middle guy that I already warned you that is gonna be the negative side. Okay, it's gonna be the negative side in order to have the correct cross product. Okay, the last thing is called the scalar triple product. The scalar triple product, I'm not gonna quite use this guy much. However, it's gonna be given in the way of the determinant that when you have A dot B cross C, it's gonna be A1, A2, A3. So it's gonna be, if I highlight, so it's gonna be vector A is the first row, vector B is the second row, and vector C is the third row. Okay, so that is called scalar triple product. However, the important thing on this scalar triple product turned out to be in order to find the volume of the parallelepiped here. So you see that it's gonna, you see the parallelepiped with the vector A and vector C and vector B like this. So if you like to find the volume of this parallelepiped, you're gonna see that you have the base. So the base here will have the area equal to the norm of B cross C. Okay, so it's going to be the norm of B cross C for the base. Okay, and you're gonna have the height. okay, you're gonna have the height given by a cosine theta. Okay, so it's gonna be a cosine theta, and you're gonna have the vector b cross c to be the vector that perpendicular to both b and c. So this guy is going to be b cross c. And the thing that you need to know is going to be the height. The way to obtain the height will be just the projection. Okay, so the way that you're gonna obtain the height, this one is gonna be the projection. Let me use the red color. So this height is the projection. Okay, so this height is the projection of A onto B cross C. Okay, so it's going to be the projection of A onto B cross C. And the H guy turned out to be A cross theta. Okay, so the H guy turned out to be A cos theta. And you see that it's turned out to be automatically A dot B cross C. Okay, norm A, norm B cross C, cosine theta. Then theta is the angle that you have A make with B cross C. So this guy turned out to be A dot B cross C. So this one will give you the volume of the parallelepiped. However, we're not going to use this formula. We're going to just compute B cross C dot A. Okay. So for this one, we like to find the volume of the parallelepiped determined by the vector A given by, okay, so this one will be 1, negative 2, negative 4. You have B given by 1, 0, negative 1, and C given by negative 1, 2, 0. Okay. So we're gonna have the volume turn out to be A dot B cross C, and you need absolute value. Okay, so this guy will be absolute value. So in this case, you're gonna have to first find B cos C. Okay, and the second step will be you find A dot B cross C, and you're gonna get the final answer. Okay, I'm gonna leave this example for you to do on your own again. Okay, I'm gonna give you the solution at the recitation. Okay, so please try to do this one, and it's gonna make you familiar with this one, and you're gonna be able to get the next idea that we're gonna cover in our lecture. Okay, so the important part turn out to be you have to be able to find B cross C correctly. And like I said before, you can check your solution by you just use B cross C dot B and dot C whether you're gonna obtain 0 or not. Okay. Okay, so that's it for all of the vector that we're gonna need for doing the next topic, which are about the straight line in 3-dimensional.